Okay, so we're going to look at how to prepare solutions today. And we're actually, most of the math you've already done before. We're just going to sort of look at it and analyze it a different way. So we're basically making a standard solution and calculating usually what mass or what volume you need to make that solution. So we're going to do two. So you either have a solid and you're going to dissolve the solid in distilled water, or you have a very concentrated solution and you're going to add water to it to make it more dilute. So we have to, our scales measure mass, right? So this is literally like I'm going to measure out the mass of whatever and dissolve it in water. So you have to use moles because we're going to look at what the concentration you want. So remember, concentration is moles per liter, and what how many liters or milliliters are you looking for? Okay, so in the last unit, if we just had mass, this is the triangle we would use. But now if we're using concentration, then it's moles per liter. So what we can do is take this mole formula, like grams divided by molar mass, and there's a common variable here, and we can take this and plug it in for moles, and make sort of a master or big triangle, if you will. Okay, so this is not going to be pretty, but so it's like basically mass over molar mass divided by volume. Okay, so if you have a fraction, then when you divide them, you invert and multiply. So the top is mass over molar mass, and the bottom is volume over 1. So if you invert it, it becomes 1 over volume. And then when you multiply mass times 1, it doesn't change. Okay, so then incorporating both of these formulas together, you get mass over molar mass times volume. You can certainly still use these two triangles here when you do these kinds of questions if you're preparing a solution from a solid. So in these questions will be different because it'll give you a volume and tell you what kind of concentration you want, or what concentration for a solution you're looking for. Then you have to take all of that into account. Okay, so you can also make a triangle for this if you would like. So concentration is mass over molar mass times volume, and the volume has to be in liters. Mass is in grams, concentration is moles per liter, and this is true no matter what form of this you use. So mostly because we're going to prepare solutions with a solid. So literally one of my SciTaf students they can do this math. I'll give them a volume. Most of our bottles are a liter, so I usually say 900 milliliters of distilled water, and the molar mass of whatever the solid is, multiply them together to get, whatever concentration you want, 1 molar, 2 molar, 0.5 molar, whatever. And then you measure out the appropriate mass. So we're most often going to use this form. Mass is C times V times MW. Okay, but you can certainly, there's a variety of ways you can do these kinds of questions. Okay, so since you've seen all these formulas already, let's just jump right into the example. How much potassium iodide is required to make 250 milliliters of a standard solution of 0.5 molar Ki? So remember that units for concentration can be big M or moles per liter, that doesn't matter. So we are looking for how much, what's the mass? Your given volume, which is 250 milliliters, but we need liters. So you divide by 1,000 and get 0.25 liters. And if your molar mass is from the last unit, if you're good at it, then you could just write the total. Here we only have 1 potassium and 1 iodide. So it's pretty straightforward. Okay, and then the concentration we want is 0.5. So we are looking for mass, we have concentration, molar mass, and volume. If you're a dimensional analysis kind of person, then if you keep the units in, they should all cancel out. Oh, I don't know what just happened there. So the moles, there they go. And the last one we're multiplying by is how many liters we want. And we're left with grams. All right, so then you would measure 20.75 grams into 250 milliliters of distilled water and get it to dissolve. So usually, by stirring, we have a stir bar, magnetic stir bar apparatus at the back, or you can use heat as well, heat up the water a little bit, not to boiling, but pretty close, and that will dissolve the solid usually. And then again, so when you're making a solution, you're assuming that the solids are soluble. Now, we can sometimes make a super saturated solution where we warm it up and get more to dissolve, but then when, let's say I'm gonna give this to Miss Dickens grade 10 class, if the solution starts to cool down, then it'll recrystallize. So that's not really advantageous. Okay, so we're assuming that, so then the 250 milliliters of distilled water, you don't add the 20.75 to that. By definition, if something dissolves in water, then it fits in between the water particles. Okay, whereas with this equation, so now this is for dilutions. So we can have a concentrated aqueous solution. Usually these are acidic. Bases you can buy solid. I've never seen solid hydrogen chloride, for example, to make a hydrochloric acid solution. We get 12 molar hydrochloric acid solution from the supplier and we dilute it. So this formula determines when the quantities are equal, but with a different volume. So again, C times V is moles, so we're just sort of manipulating that. You might see this formula as C initial, and V final. So C1V1 equals C2V2. So 1 is the more concentrated solution. So you would take a small volume of this, smaller than the second volume, and add water to it. You can't analytically evaporate water and expect to be able to predict what the concentration is going to be. Evaporation cannot easily be controlled. But if you have a stock solution that's more concentrated, then you can easily calculate how much of it to use based on what concentration you want to end up with and what's the volume you want to end up with. So 1 is the initial, which is more concentrated, often called the stock solution, and 2 is the final solution you want, which is less concentrated because it has more water in it. So V2 or V final should always be larger. Okay. So what volume of 3 mole per liter sodium hydroxide would be required to make 250 milliliters of a 0.15 molar solution? And then we're going to explain how we're going to prepare this solution. So it's a little bit different than the last one. Okay, so C1V1 equals C2V2 is when you're making a less concentrated solution or diluting. And so as with most formulas, there are four possible variables. You would be given 3, and you just have to figure out which one that you are looking for. So this formula itself is not very difficult. Usually the only struggle is students often, does it go on the left side of the equation? Does it go on the right side? You just want to make sure that the correct concentration goes with the correct volume. So the more concentrated solution goes with its volume, and the less concentrated or dilute solution goes with its volume. So I'm going to write out all my knowns and unknowns. So we have 4 possibilities: C1, V1, and C2 and V2. Okay, so this is concentrated, right? C1. So 3 molar and 0.15 molar. So 3 is greater than 0.15. So it's the concentrated solution. And then C2 is the dilute, which is 0.15. And it says and actually this question is very well worded. What volume of the 3 molar solution would be required to make 250 milliliters of this solution? And again, we want to make sure our units match, so I'm going to divide by 1,000. You can decide if you're the kind of person who likes to rearrange an equation with the variables first, then you can do that, or you can do it this way. So now we've got the liters canceling, and you're just left with moles. And then you need to divide by 3. That was terrible. So moles on the top cancel, and so you're left with liters. Okay. Now it says, explain how you would prepare the solution. So you're going to measure the concentrated solution first. So you're going to measure, we usually measure in milliliters, right? So we have to change this back into milliliters. So that's, none of our graduated cylinders measure liters. So 12.25. So that makes sense because we want the volume for that to be smaller than the 250, which it really is. But now, we already have some milliliters. So the volume of water you're going to add is, you want the final volume to be 250. So you're actually adding 237.5 milliliters. So you have to subtract so that you don't go above the 250. Okay, so the first set of questions in the homework are the preparing a solution from a solid, and then the second section of questions are practicing dilution. So do a couple of each. All right, thank you.